Hey, welcome back, AP Calculus students. Today we're doing part 2 of slope fields and Euler's method. Sorry, said that wrong. Um, so we're actually getting into the slope field stuff and the Euler's method stuff today. The stuff before was kind of just a little bit more on the antiderivative and stuff from part 1. So what slope fields are they show the trend of graphs for the antiderivative. So y, given the differential equation dy dx. That's because the derivative gives the slope at the point. So it's not that hard of a concept to understand, and you can kind of see how this is going to work out when we start doing our slope field. So in this first example, we're looking at the derivative dy dx. This differential equation is equal to cosine x. So what we want the slope field to show is the graph of y, and that's super helpful because sometimes we have a differential equation that has x's and y's, and it's not quite clear what the y would be, and it's not that easy to just do the antiderivative to get there. So what we're going to do here is we're going to do the slope field for cosine x, and because we all know that the antiderivative of cosine x is sine x, then our graph should look like sine x in the end. So let's go ahead. Now what we're going to do is we're just going to put the slope at every point here. So let's label this graph. So notice that the x-axis has already been labeled. So each of the jumps on the x-axis is by pi over 2. So it starts at 0, pi over 2, then our next one is pi, then 3 pi over 2 until we get to 2 pi. And the reason why we're doing that is because we're looking at a cosine, and we know one cycle of cosine, its period is 2 pi radians. So let's start at the 0. So what we're going to do is we're going to plug in, technically we're going to plug in our x and our y for our point, but because our function only has an x in there, we're going to only be worried about our x. So when our x is 0, the cosine of 0 is 1. So for each of these points, we're going to represent a little tick line with a slope of 1. Okay, then we'll move on to the next one. So our x is pi over 2. So cosine at pi over 2 is going to be 0. So we're going to do 0 slopes for all these points. Then we're going to go over to pi. So cosine at pi is going to be -1. So we're going to do a -1 slope through each of these points. And then we move on to 3 pi over 2. 3 pi over 2, our cosine is going to be 0 again. So we draw a horizontal slope for all of those points. And then at the very end, we have 2 pi. So the cosine at 2 pi is back to 1. So we're just going to draw a slope 1 through all those points. Now this might not look like a lot to you. It's just a bunch of tick marks, but the hope here is that, let's change colors. Let's start at this point here. Okay, if we follow our curve here to the next point, and then here, and then here, and then back up to here, what we're doing is we're drawing, notice that purple one is the graph of sine x, and we can follow the pattern for all of these. And we end up with, oops, let's not do that last one because it goes below the graph, but we end up with a bunch of sine curves. Okay, so let's try this same idea using slope fields on a different equation. Now this equation is going to have an x and a y in it. So our dy dx is going to be x plus y. And we're going to do less points here. We're just going to keep it simple. And it says construct a slope field for dy dx, and that passes through 2, 0. Okay, so let's go ahead and do this. So what we're going to do is we're going to put in our slope field. So let's start at 0, 0. So at 0, 0, right in the middle of the graph, our x is 0, our y is 0, so then our slope here would be 0. Okay, so I guess let's go along the y-axis and x-axis first, and then let's see how it goes. So let's move up to this point. That's going to be at 0, 1. So when I put a 0 in for our x and a 1 in for our y, then we have a slope 1. So we represent our slope 1 with a diagonal line. Then let's go up to here. This one would be 0, 2. So 0 plus 2 is going to be 2. I'm going to make my slope a little bit steeper. Okay, then let's move down here. That's going to be at 0, negative 1. So 0 plus negative 1 is negative 1. So I'm going to draw a slope of negative 1. And then at the bottom, it's 0, negative 2. So 0 plus negative 2 is negative 2. I'm going to make that slope a little bit steeper. Okay, we're going to continue the process. So let's go over to let's do the negative side first. So that's going to be 0, negative 1. Which is negative 1. This is going to be negative 1, negative 1. Or negative 1, positive 1, which is 0, sorry. This point here is going to be 0, 2. I mean negative 1, 2. So negative 1 plus 2 is 1. This point is negative 1, negative 1. So negative 1 plus negative 1 is negative 2. I'm going to make a steeper slope. And then negative 1, negative 2 is negative 3. So an even steeper slope. And then let's move on to the last negative section. This is going to be negative 2, 0. So that's going to be a slope of negative 2. This is negative 2, negative 1. So that's going to be negative 3, negative 4. This one is going to be negative 2, 1. So that's going to be negative 1, which is a little less steep. And then this is going to be negative 2, 2. So that's going to be 0 when we add them up. Okay, now over to the right side of the graph. This point here is going to be 1, 0. So that's slope 1. This is going to be 1, 1. So that's slope 2. This one's going to be 1, 3. So that's slope... Oh, sorry, 1, 2. So that's going to be slope 3. This one is going to be 1, negative 1. So that's slope 0. And then 1, negative 2, which is slope negative 1. Okay, and then the last row here, that's going to be 0, 2. This one's going to be, 2, 0 for the last one. This one is going to be 2, 1, a little bit steeper. And this is going to be 2, 2, so that's slope 4. And then this one here is going to be 2, negative 1, which is slope 1. And then slope 0 there because that's 2, negative 2, which is 0. So now it's asking us that passes through 2, 0. So what we're going to do is we're going to locate our point 2, 0. So that would be at 2, 0 here. And we're going to try to follow the trend of the curve. So if you look here, it kind of, if we follow this trend, it looks kind of like this. Alright, so we're following the slopes of this curve to kind of draw where this graph is heading. So this would be a slope field for y equals, or this is y passing through 2, 0. Okay, so just to recap on the slope field, what we're going to do is we're going to be using our equation, and we're going to take the x and y coordinates of each point and then determine what the slope is from our equation. Okay, and then Euler's method, Euler's method, Euler's method, Euler's method. I'm getting myself confused here. Euler's method. Let f be the function that satisfies dy dx equals x plus y and passes through to 0. Use Euler's method and delta x equals 0.2 to approximate f of 3. Okay, so the whole idea here is it's another means of approximation. So we're starting off with some line and we're making it ever and ever closer to the approximate. So let's say this is what our function looks like. I don't know what our function looks like. Okay, so it's saying we're starting at 2, 0, but we want to approximate this function at 3, right? Wherever x is 3. So what we're doing is we're just going to take one approximation and then we're going to get a little bit closer approximation, a little bit of closer approximation, and a little bit closer approximation. So each time we move a little bit ahead, it gets more accurate. So each time we do another approximation, it's going to jump ahead delta x. So that would be 0.2 units until we get a pretty good approximation when we reach the end. Okay, so we do need a starting point, right? That's 2, 0. We do need our function, that's x plus y. And then we're just going to go ahead and use Euler's method. So what we're going to put in here is x, y. We're going to put in the starting point, 2, 0, right? We got that from our top. Then we have to know what our dy dx is, right? So that's our function. And we're going to plug in our x and our y here. So dy dx, and you don't have to write the dy dx every time, equals 2 plus 0, which is 2. Okay, our change in x is not going to change, right? That's 0.2. And then these things are going to calculate from what we just already put in there. So the change in y is going to be the dy dx, which is 2, right? Dy dx, times the delta x. So 2 times 0.2 is going to be 0.4. So again, to get this column here, we just multiply the two columns in front of it. And then the last step is we're going to do our x plus delta x. So our x is 2 plus delta x is 0.2. So that's 2.2. And then our y plus delta y is going to be our 0 plus, we found delta y in the fourth column. So 0 plus 0.4 is 0.4. Okay, actually, let me just change colors for the next row. Okay, so we're going to take this thing, we're going to put it here now, 2.2, 0.4. So we're inching closer, right? So this x is getting closer. So what happens is that our y should be getting closer to a better approximation of f of 3. So we know we're going to stop when our x is 3 because we're looking for the function value or an approximation of the function value when x is 3 here. Okay, we're going to repeat the process. Dy dx is x plus y, so we're going to do 2.2 plus 0.4. 2.2 plus 0.4 equals 2.6. Change in x is still 0.2. The change in y is going to be dy dx, which is 2.6, times delta x, 0.2, which is going to give us 5.2. No, 0.52. Missed the decimal place. 0.52. And then we're going to do that last part again where we add our x and our delta x. So 2.2 plus 0.2 is 2.4. And then y plus delta y. So our y is 0.4. our delta y is 0.52, so this is going to be 0.92. Right, we're adding our sorry, where did I go? We're adding our delta y with our y to get 0.92. Okay, column 3, we take our point, put it back here, 2.4, 0.92, and we repeat our process again. We're finding dy dx, that's going to be 2.4 plus 0.92, which is 3.32. Change in x is still 0.2. Our change in y is going to be dy dx 3.32 times delta y. I'm going to use my calculator here. So 3.32 times 0.2 is 0.664. And then we're going to do our x plus delta x. So 2.4 plus 0.2 is 2.6. Notice that the x is just increasing by 0.2 each time, which is what we expect, right? Because the change in x is 0.2 and it's constant. And then the last part, we're going to do our delta y plus y. So 0.664 plus 0.92 is 1.584. Okay, let me erase this bottom because I think we're running out of room. Okay, so we take our 2.6, 1.584. We repeat the process. So x plus y is going to be 4.148. 4.148. This is still 0.2. So 4.148 times 0.2 is 0.8368. 0.8368. And then this is going to be 2.8, right? Because we're just adding 0.2. And then our y is going to be 0.368 plus 1.584. 1.584. 2.4208. 2.4208. And then this will be the last, oh, it won't be the last time. Yeah, it will be the last time. 2.81, oh, sorry. 2.4208. I'm just going to use this purple from here on out. Okay, so x plus y plus 2.8. 5.2208. Delta y is going to be 5.2208 times 0.2, which is 1.04416. So then when we have 3 for our x, our y is going to be 1.04416 plus 2.4208, which is 3.46. 3.46496. Okay, so this would be our approximation. Now let's see what the actual value would be for this. The actual value Where's my book? Okay, so the actual value for this one would be... Oh, we can't find an actual value. Alright, so this will be our approximation. Okay, so let's recap what we did. So we need to have our function, right? We need to have our derivative function. So notice we start with the derivative. And it's a differential equation, so dy dx is equal to x plus y. We have both an x and a y in there. And it passes through to 0. So we need a starting point. Our starting point is 2, 0. And it's asking us to use Euler's method. And it's giving us our change in x, which is 0.2. And we're using that to approximate f of 3. So we know that we're done when we get to our 3 for our x. So you're going to start off first column. We're starting off with our starting point 2, 0. And we're just using our calculations, right? So we're calculating our dy dx, our derivative function, by plugging in our 2, 0. And then we're going to do our change in x. That's not changing. Then we're going to find our delta y here. And we're going to do that by combining our dy dx and multiplying it with our change in x. And then the last step here in the last column is we're going to be doing x plus delta x. So the x column should be constantly changing by the same amount. And then we're going to do our y plus delta y, which we just found in the column to the left. And then we're going to take our point here and bring it back to the left side and repeat our process all the way until we reach our 3, because it's asking us to find the f of 3. So what it's doing is it's approximating, but the cool thing about this is it's approximating starting off. So it starts with the derivative, dy dx, and it's approximating a value for our function y. Okay, so that's it for today. Make sure you get comfortable with slope fields and Euler's method. Slope fields for sure you can expect to see on your end of course exam in some capacity, and possibly Euler's method. I'm not sure if it's going to ask you to do the whole thing or remember the whole thing, but it might give you a table and have you calculate an approximation using Euler's method. All right, good job.